Then I showed you the concrete, where you have to cast the profiles within the concrete and provide your wiring conduit infrastructure. So these are the design details you want to be mindful of. I'm going to show you one drawing so you can get an idea of how details are integrated. So you could see that there's a special profile that looks like this, and we're integrating it into tiles. Now you'll notice that the profile, this has to be installed before we install this and this, because if you try to install this, people have left out this tile, and then we can't, then the tile guy has to install at this level below. And you can see the wiring details. It's parallel low voltage wiring like this. I don't think this drawing has much wiring details, and you can see how the lights are being connected. Let's move into the engineering. I'm just going to quickly show you an example of what these calculations might look at. So let's use this one. We have 20 treaders. So let's use this scenario. We have 20 tread or 20 stairs. So let's open a little text box here. So I have total stairs equals 20. Now you're going to have to measure the width of each stairs, and let's just say it's 3 feet, or which is roughly 1 meter, 3.5 feet. So we're just going to say 3 feet. So we know our total distance or total material will be 20 times 3 feet equals 60 feet. Now we know that not all LEDs could run 60 feet continuously unless there was a special IC chip in it. In that case, you could literally run stairs to stairs like this. But then the wiring conduit of it may be difficult to pull off. So you may just want to come on the sides using this method. So you have to know the scenario to see what works. But we're working on calculations here at the moment. So I have 60 feet of LEDs. That's roughly about 18 meters. And let's just say, for argument's sake, we're using let's say the wattage on this LED is equal to 1.5 watts per foot multiplied by 60 feet. And we're gonna get about 73 watts. And I like to round it up, so let's say 74 watts. Now, we know if it's residential use, commercial use, we add that factor in. So you look at your equipment, you cater for your power factor, and let's say it's residential use, and your power supply had that power factor, and I'm just roughing it out to 1.25. So we're gonna say 74 watts multiplied by 1.25, because the 20%, and we keep in an additional 5% for the power factor. So 74 times 1.25, and that's equal to 92.5 watts. And I'm just going to round it up to 93 watts. And the key thing is we forgot about the voltage. So let's just say the voltage here in this job was 12 volts. And we're going to round this up to roughly, we need 100 watts. Now we know that if using a class 2 power supply, we can't go beyond 60 watts at 12 volts DC or 96 watts at 24 volts DC. So we're going to have to use two 60-watt power supplies. And let's get some facts out of it. And we know we have 60 feet of LEDs. And we're going to split into 4 circuits. So we get 15 feet of LED, or 5, because each treader is 3 feet, or 5 stairs. So that means we're going to have a parallel run like this coming into a distribution box. We're going to have 3 feet here, 3 feet here, 3 feet here. Now I said keep it at 12, but I'm just giving an example. 12 if it's far away, but it's not too far away. So we have 5. 1, 2, 3, 4, 5, and then we're going to go into our next parallel run and power another 5 stairs. So those 5 stairs consist of 15 feet total of LED, and if we do that 4 times, we're going to get 60 feet. So let's work out the math. That's going to be 15 feet multiplied by 1.5 watts per foot. That's equal to 22.5 watts. Now, because we're using 60-watt power supplies, we're going to load 2 circuits on that. So we're going to have on that power supply 22.5 plus 22.5 watts, and that's equal to 45 watts. And let's just see if we're okay with space. Yeah, so that power supply is only being loaded 75%. So we're okay. It's only being loaded 75%. Let's check the amperage on those wires. So on that main parallel wire, which is this main wire right here. The amperage on it is going to be 45 watts divided by 12 volts, and that's 3.75 amps, which is really small. However, if you have to factor in voltage drop, you want to look at probably 11 watts or probably the wattage you'll get at this area here. That's really small. So you now have to determine what gauge wire is going to be used, this main green wire across here. And you would just use your voltage drop calculator. So let's go to a voltage drop calculator. This one considers the power factor. The wire is copper. Let's just say we're using 14. Material of conduit, it's PVC. Power factor using 24 volts. It's a single set of conductors. And let's play with the distance quickly. Let's say this is 20 feet away. The current load was 3.75 amps at 12 volts. So the voltage drop is very nominal. It's 3.89%, and we don't want to go below 11. Let's see if we change it to 24 volts, what will happen. See the percentage drop because it's a higher voltage. So let's go back to 12, and let's say it was 100 feet away. Yeah, so that's not good. So if it's 100 feet away, we're gonna have to put in another parallel wire and probably reduce the stairs to, instead of every 5 stairs, what you might have to do is reduce these stairs like this. So you have 3 parallels, and those 3 parallels would now split into 6 parallel drops as opposed to 4 parallel drops. And then in your furthest treader away, you just use 2 stairs. So you reduce the load so it handles that extra length of the whole staircase. So you would reduce the load to probably two treaders as opposed to 3. So understanding distance is very key for the engineering, and a lot of factors could play around. We could spend here all day chatting about it because we've had so many scenarios, and this is just a framework to help you quickly think through the engineering for using these stairs lighting. Again, be careful on the control modules you're using. Naturally, if your control modules have maximum amperages, be mindful of that because it could really affect how your controllers or your fancy controllers perform, whether it's RGBW, whether it is the motion sensor controls. Be mindful of your ratings. Thank you guys. We're going to go into a live stairs installation, and we're going to talk you through what's happening, and you can see how we attack this job just to consider all the factors from this. See you then.